Okay, YouTube, in this video we're going to finish up our exploration of solving radical equations, but in this video we're going to highlight kind of a unique thing that happens sometimes in an algebraic approach to solving things, but extraneous solutions. Now, extraneous solutions, you can see the root of extraneous solution here is extra. So sometimes what we do is we work this out algebraically, just like it makes sense, but you get answers that don't make a whole lot of sense. So what we're going to do is we're going to make sure we check these by plugging them back in. So looking at this first equation here, solving radical equations wise, we've already isolated the root here on the right side. So what we're going to do is we're actually going to undo the root by raising to the appropriate power. So we're going to square both sides. Now here, this is very important, but we actually have to square the entire side, okay? So as far as the right side goes here, I'm very well aware that, well, the square root of something squared is just that thing. But on the left side, we actually get x minus 4 times itself. So we're actually going to need to FOIL this out here and simplify what we get. So this leaves us with x times x, so x squared, minus 4x, negative 4 times a negative 4 is a 16. On the right side, we get 2x. So let's go ahead and clean this up a little bit here. At the very least, we say x squared minus 8x plus 16 equals 2x. And so the important thing is going to be this. We're going to need to, since we have an x squared and an x to the first, we're going to try to set this equal to 0 and factor it. So our method that we've seen before with polynomials, we're going to go ahead and clear a side and get 0 on that side. And I have to take these two x's away from the x's to the first over here, so I get negative 10 total of these. I say plus 16. So if I'm going to factor this, I notice it's a trinomial with an a value of 1. So this would factor into two factors of a positive 16 that add up to be a negative 10, and I can consider it be negative 2 times negative 8. So our two factors would be x minus 2, x minus 8 equals 0. And when we set each of these factors equal to 0 and solve, like if x minus 2 equals 0 and x minus 8 equals 0, then we get x equals both 2 and x equals 8. So I'm going to put a box around both of these, and we're going to say solutions, question mark. The idea is that you have to check both. We need to check both. So if we plug this back in, our original equation said x minus 4 is equal to the square root of 2 times x. Check this out. If we plug back in now, let's plug in our 2. If I plug in a 2, I get 2. You can see here on the left side I get negative 2, and on the right side I get the square root of 4, which is 2. So I get negative 2 equals 2, and this is very bad. So what this means is this thing right here is not a solution. Not a solution. And actually, what we're going to write here is this. It is extra, or extraneous. Let me get this right here. A-N-E-O-U-S. Extraneous. Okay, so we're going to check our 8 here. Let's try this again. We'd say that if I plugged in an 8 minus 4, we get the square root of 2 times 8. And so we end up with this here. 8 minus 4, which is 4, is equal to the square root of 16, which is 4. So that solution is valid there. Okay. So again, really quickly, in this instance, we would get the root by itself. Root's already by itself, so we're going to square both sides. So in this case, we square. So we get x plus 2 times itself. We have to write this out. X plus 2 times x plus 2 is equal to 2x plus 28. Again, we need to FOIL this. So we get x squared plus 2x plus 2x plus 4 is equal to 2x plus 28. And then furthermore, we say combining like terms, we get x squared plus 4x plus 4 on the left. When we combine these two x's to the first, we get 2x plus 28. So now the trick here is we've got to clear an entire side. It seems to me that it is easier to clear this entire right side at once. So we're going to take away 2x from both sides, take away 28 constants from both sides, and we get left with this, x squared plus 2x minus 24 equals 0. And this is great because we get another trinomial with an a value of 1. So we could say, can we think of two factors of negative 24 that add up to be a positive 2? And I would think that it's a positive 6 times a negative 4. Okay, so our factors are these. We say x plus 6, x minus 4 equals 0. So if we were to set each of these factors now equal to 0, x plus 6 equals 0, we say x plus 4, x minus 4 equals 0, minus 4 equals 0, then we get two solutions. We get x equals negative 6 and positive 4. And you do need to check both of these. So really quickly, I'm going to check them again. We say x plus 2 is equal to the square root of 2 times my input plus 28, where if I put in a negative 6 for an input here, I hope you can see that this doesn't work. We get negative 4 on the right, but on the right side we get negative 12 plus 28, which is fine because we get negative 4 is equal to the square root of 16. It's just that the square root of 16. In this case, we say its principal square root is 4. So we would say that this does not work here. So 6 does not work. I'll leave it up to the viewer to show that when you plug 4 back in here and here, consider that, okay, that you get a true statement. So 4 is a solution. But that's how you determine extraneous solutions. You check your answers. Cheers.